All right, we're going to finish up chapter 20 here. We're going to talk about carbohydrate derivatives. I'm going to focus on the notes here simply because you guys can all read this. When we get down to blood type, that'll be pretty interesting. These glycoaminoglycans, or GAGs as they're called, what a great name. These are unbranched carbohydrates, all right? And they form, it's like a gel-like matrix, all right? And that gel thing is actually really important because we need like that squishy stuff in between our bones. Uh, and so here we have hyalurate, excuse me, uses beta linkage. By the way, this is our glycosaminoglycan. And so you can see it gets amino because there's an NH2 group right there. What this stuff is extracellular fluid for your joints. That's good because we need squishy parts between like our femur and our shin bones. It's also the vitreous humor of the eye. It's kind of why I like our weirdo organ there is kind of squishy. Uh, Chondroitin, you've probably heard of this. You can buy this at the store and take it as a supplement. It utilizes beta linkage, if you remember what that is. So it's like you have one thing and then below it and then below it. And then this is for cartilage and tendons. So I'm hoping I have plenty of that in my system. And then heparin, this uses alpha linkage, that's the word. And this is stored in your mast cells and it prevents clotting. So this is actually pretty good because it means that your blood is flowing and all that stuff. Chitin, this is kind of weird. It's the second most abundant carbohydrate polymer. So it utilizes this N-acetyl D-glucosamine, and this is what we have here. This is where that N-acetyl thing comes in. It uses 1,4 beta linkage, and it's just like cellulose, except it's got this chunk right here. And as you can see, I've written down here, it's in the exoskeletons of shellfish. And so this is utilized in a lot of different shells. So it's kind of like a weird little compound. And then these carbohydrate derivatives actually play a big role in blood type. We've all heard of our blood type, type A, type B, type AB, type O. And so down here, I've written kind of everything that's going on. All right. So everybody has, no matter what blood type you have a D galactose unit, an L fructose unit, and an N acetyl D glucosamine unit. So these are the three chunks that are for every blood type. All right. If you have type A blood, you have an extra monosaccharide, and it's this. It's N-acetyl D-galactose. See, here's glucosamine. This is galactose. And so you have an extra sugar. That makes it type A. Type B doesn't have this. What it has an extra D-galactose unit. All right? Then, sorry, D-galactose is right here. Then type AB actually has 5 sugars. It has these 3. It's got the extra D-galactose, and it's got the thing from type A. If you have type O blood, all you have are these 3 sugars. This is actually making kind of, perhaps you've read articles about it or something, but they're finding that the coronavirus is actually people with type A blood are slightly more susceptible to it than people with type O blood. I'm not sure of all the workings of the virus due to blood type, but what that means is that this compound right here that's attached to type A blood types somehow interacts with the virus more than if you just have the 3 sugars. So it certainly doesn't mean immunity or anything like that. It's just they're finding that type A blood is a little more prone to infection than type O blood. Hopefully this was a good presentation for chapter 20. You have to read the book. I'm going to keep beating that drum. If you don't read the book, you're going to get behind. I'm going to be putting homework assignments up and things like that. I will make some practice problems like we had on our Wednesday discussion sections, like what we would do after lecture. So I'll put those up as well as a separate answer key. So you'll have a lot of different things to look at.